Hey everybody, Mr. Bowman here. This video is in relation to the Year 10 end of year exam preparation. Specifically, we're focusing on the practice exam that I wrote to make sure everyone's all prepared, ready to go for that. So first thing to note is that's what your front cover looks like. The next two pages, the first page is going to be a huge formula sheet, so you're going to have all the formulas and equations that you need there. And then finally, after that, there's going to be your geometric reasoning. So you don't need to memorize these reasons, but you do need to know how to apply them. So let's get straight into question or section number A. This is the 20% geometry section. A whole lot of reasons. And before we start, as always, let's read the instructions on the timing. So this section is worth 20%, which means you should be spending 20 minutes on it. So as soon as you hit that 20-minute mark, stop, move on to the next section. And if you got time, come back to it. But you don't want to miss out on full sections to do this one here. So let's get into question number 1, which is a multi-choice question. So we've got the following, or which of the following shapes has two pairs of parallel lines and no right angles? So I guess the first thing to note is a square. It's good on the parallel line front. We've got two sets of parallel lines, but obviously with a square, all of those are going to be right angles. So we know it's not going to be a square. Same thing with the rectangle. We know they're all going to be right angles. A trapezium, this one sounds like a good answer, but it's not quite right. There's no right angles there, although there actually can sometimes be right angles. And specifically, you know, that top and bottom, those lines are parallel to each other. So there's only one set of parallel line. And actually, in theory, this type of trapezium here, let's draw a line there. You know, that's the parallel lines there. And actually, there are right angles in some trapezium, so that's not quite right either. And then finally, the parallelogram, that's when you got one to look like this. You've got parallel line at the top and the bottom. The two sides will be parallel, and none of those angles at the top and bottom will be right angles. That means our answer is going to be D, parallelogram. Let's get into question number 2 now. Which of the following angle name represents angle T? So of to note, angle T is the one here. So we can see that there. Let's draw it in clearer. A lot of people, when they did the practice exam, said, hey, sir, there's no right answer here. But this one, if you follow it and just do line by line, or so option by option, you will get to the right answer. So, for example, DBG, so that tells us you're going to start at D, you're going to go to B and go down to G. That there is not quite angle T, so it's missing a little bit, so we know it's not that one there. Then we've got DEF. So starting at D, going to E, going to F, that means this angle here is DEF. That's a right angle, but that's not angle T either. We've then got FBD. So we're starting at F down here, up to B, and then across to D. Bingo. So that's exactly the one we're looking at. And then just, you know, BAD was a weird one. It started over here, went up that way, and then back down that way. So that was just a straight line, really. So that wasn't the option. So C was the correct one for that. So now on to 3. Which of the pairs of angles are alternate angles? So before I look into the options, let's not look at the options. The alternate angles, they both have to be inside the parallel lines. They've both got to be inside these parallel lines, and they've got to be, if you see this bisecting line cutting in this way here, they've got to be on the opposite sides of the bisecting line. So that means 5 could be alternate with 3, and it means 2 could be alternate with 8. So if we have either of those combinations, we're going to have the right answer. You can see all of them have a 2 in it, so we know it's not going to be the 5-3 combo. That must mean it's going to be the 2-8 combo. So now to question number 4. What is the external angle of an equilateral triangle? And this here is an achieve mark. So I would start by, again, not reading the options, because those people just tend to guess and get it wrong. So I've got my equilateral triangle. I know all of those are like that. I also know that all my angles inside are going to be 60 degrees, right? So that's my equilateral triangle. An external angle, so imagine if we extend one of these lines. So let's extend this line here. We create the exterior angle here, the external angle. And it's basically asked us, what's this angle here? And the nice thing about that is we can see if we draw a squiggly line down here, 60 and that unknown external angle are all sitting on the same line. So it means they've got to be summing to 180 degrees. So we're going to go 180 minus 60, and that there is equal to 120 degrees. So that external angle of an equilateral triangle has got to be 120 degrees. Finally, another achieve mark, actually. So question number 5, what is the sum of the total internal angles of an octagon? So there's a few bits of knowledge you need to know here. So firstly, you need to know how many sides does an octagon have. And if you don't know, that's an 8-sided shape. So that there's going to be 8-sided. And you also need to know the formula that's relevant. So in your formula sheet, we had a formula that was 180 n minus 2. That tells you what all of the angles inside a shape, if you added them all up, it tells you what that total is going to be. And really important, in that formula, n is the number of sides that the shape has. So let's apply that maths to our 8 sides. So we're going to take away n, put in 8. So that there is going to be 180, 8 minus 2. So that's going to become 180 times 6, and when you do the math on that, that's going to be 1080 degrees, which is option A. So we're now into the big section. This is where the big wordy geometric reasoning questions come in. So there's 6 to 12 is what we're aiming for here. And of specific, it's going to emphasize this throughout. If you don't have any geometric reasoning, you're not going to be able to get any marks other than developing. So a developing student will be able to get the angles, but not really know why. An achieved student will be able to get basic angles with some reasoning. Merit students will be able to do multi-step questions. And excellent students will be able to apply weird angle rules to kind of specific shapes such as regular polygons. So let's get straight into question number 6. So determine X is the question. Your answer must include geometric reasoning, and you should include new angles in your diagram to support any reasoning. So I guess the first thing to note is, what does that thing, include new angles, what does that actually mean? So for example, maybe, this line here, I'll put the Y there. So this angle here, maybe you need that to then go ahead and calculate X. What you could do is you could draw the angle, put in Y, and then you could go ahead and talk about Y. So it's talking about adding it in. So in our case here, we actually need this angle here. So let's call that one there angle Y. And that one there is vertically opposite with the angle we're given. So that means Y must be equal to 38 degrees. And that's because vertically opposite angles are equal. And I'm just noting I copied that directly from my geometric reasoning sheet, which I had in front of me. Your job in the exam will be to do the same. Don't try to be lazy and take shortcuts. Write it out fully to maximize your mark. And I guess the next thing to note is the type of triangle we're dealing with. We can actually go straight to X. We've got an isosceles triangle because those two things are the same there. So that tells us these bottom two angles, X and the missing one there, both of those are going to be the same because you've got base angles of an isosceles triangle. So what we need to do is to find out X, we need to apply the triangle rule. So there's 180 degrees in a triangle. I know that the top angle is 38 degrees. So that number there is going to give us what these two here have to add to. And then because it's evenly split, because they're equal, I'm going to go divide by 2. So when I do that on the calculator, I get 71 degrees. And that there is our answer for X. I've got to state my reasoning. That was my base angles rule as well. So I'm going to write down base angles of isosceles triangle. Isosceles triangle are equal. So if you can get both of those, that's going to get your achieved mark. If you only get one of them, or maybe the beginnings of it, that would be your developing mark there. So moving on to question number 7, we're still on the achieved stuff, but the diagram below includes a type of triangle. So you can see this triangle here, and it's got with one exterior angle. So that's the 152 degrees there. That's your exterior angle there. What type of triangle is it? Justify your answer. Include all geometric reasoning that supports your answer. So the type of triangle could be one of 3 options. So we need to explore these. So it could be an isosceles triangle. It could be an equilateral triangle. I won't write this up fully. Or it could be a scalene triangle. So to figure out which one we have, we need to look at the 3 angles of the triangle. If we have all of them are 60 degrees, it's going to be an equilateral triangle, and we already know it's not because we can see 107 degrees there, so let's actually cross that one there. If we've got 2 angles the same, 2 same, we know it's an isosceles triangle, and if we've got all of them are different, so none that are the same, then we know it's going to be a scalene triangle. So let's do the math. So let's start by putting in another letter. Let's put an angle Y there. So angle Y is going to be equal to 180 degrees minus 152, and that's because we're going to apply the straight line rule. So we can see angle Y and 152, they're joining together on that straight line. When I do the maths for that, I'm getting, is that 28 degrees? I think it is. Perfect, 28 degrees. And then I've applied my straight line rule to get that. So I've got angles on straight line sum to 180 degrees. Okay, so I've got angle Y. I'm now going to figure out angle X with my triangle rule. So angle X, so I'll just put bullet points here. That's my first point. This is my next point over here. Angle X is going to be equal to 180 minus 107 minus the 28 we just figured out. And when I do all of that math, that gets me to 45 degrees. And to get that 45, we did our 180 triangle rule to do that. So we're going to talk about the triangle. So angles in a triangle sum to 180 degrees. And then finally, we can write them in our diagram, make more sense of it. So I know that one there is 45, that one there is 28. I can see my three angles are all different. So that tells us we've got a scalene triangle. So that can be our final thing. I'm just going to note my pause button's kind of in this area here. So I'm going to kind of write from this side onwards. So my final point, all angles in the triangle are different. So we have a scalene triangle. And I want to know, this question here seems rough for achieved, but in reality, all we applied here was a straight line rule and a triangle rule. So that's year 9 knowledge, so I can't give you any proper marks for that. But by solving a problem with it, i.e. the scalene triangle part of it, I can give you marks for that. So that's why that part there is needed for achieved. So now on to question number 8. This is our last achieved question, I think. I think the rest are merit or excellence from here. Basically, calculate X, include your geometric reasoning. And we're going to do the same straight as previously. So there's no way I can go from here straight to figuring out X or here straight to X. I just don't have that detail. So what I need to do here is I'm going to need to put in some new angles. I'm going to call it Y, maybe Z if I need more, to then go ahead and calculate it. So the first thing that I noticed was the parallel lines kind of going up and down here. And that's denoted by the arrows on the top of them. So we know they're parallel. So what we can do is this angle here, let's call this one here angle Y. I know that's going to be corresponding to this top angle here of 61 degrees. So what I can do is I can state that Y is 61 degrees. So let's get into that first. So we know that Y is equal to 61 degrees, and that's because corresponding angles in parallel lines are equal. Okay, and I want to note there's a few other ways to do it. I'll highlight a few more other ways at the end of the video to do that. And now that I've got that point there, I've now got all those points on a straight line. So I know X plus Y plus 75, all of that has to be 180 because they're on the same straight line. So that means angle X has got to be the 180 degrees of a straight line minus the 61 of Y minus the 75 given to us in the diagram. When we do all of that, we get to 44 degrees, and that was the straight line rule in action. So angles on straight line, line I'm writing there, straight line, sum to 180 degrees. And just like that, we've got our our achieved mark to wrap that up. I want to note, so this was just two pretty basic angle rules, but because one of them was a parallel line rule, that's kind of, or the parallel line one up the top there, that's kind of seen as a higher level skill for year 10. So that's why you get an achieved mark for a simple application of parallel line rules. Just noting, there were other ways to solve this problem here as well. One way potentially could have been to go to a vertically opposite angle here. Or you could have done, the straight line rule to find that angle there. And then once you had that, you could have done, maybe co-interior to get to Y. You could have figured out somehow, this angle down here, and then you could have maybe used the triangle rule to get to X. So a few different ways. No matter which one you picked, you would have got the same marks, as long as your way was justified with reasoning. So now to question number 9. This is the first of the merit marks, and it gets a little bit annoying, but there's nothing too difficult here. The annoyance I've added on here is the algebra requirement of this section. So form an expression for angle Z. So in terms of Y, I just want to note what that actually means. So that means our final answer is going to be Z will be equal to some kind of algebraic expression where y is part of the thing. So we can't find the exact angle for z, but we can come up with, something like, oh, it's going to be y plus 12. So we know it's going to be some kind of relationship with angle y to get to angle z. So two ways to do this one. I'll show you the easy one first. So by using the higher, more complicated geometry rules, the external angle of a triangle rule. So I know the external angle of a triangle is equal to the opposite two angles. So I can actually solve this one really quickly in one step by doing that. So I know that angle Z is going to be equal to the other two angles added together. That's going to be 90, or y plus 90 degrees, right? Y plus 90 degrees. And that there is external angle of triangle equals to the sum of the opposite two Okay, so I should note that was the easiest way to do it. There was another way to do it. It was slightly more complicated, but you'll get to the same answer. The nice thing about the other rule is it applied simpler geometric reasoning. So the other method required you to kind of come up with an expression for A first. So I'm going to do that up the top here. So A sits inside the same triangle as the right angle and the y. So that means A would have been equal to 180 minus the other two angles. So minus 90 minus y. And that there would get you to 90 minus y. Now that you've got A, don't forget your reasoning if you're doing this method. I won't write out the full reasoning here. But now that you've got A and Z sit on the same straight line. So that means if you did Z, that's 180 minus A, right? And we know that A, so it's 180 minus, don't forget to put it in brackets here because I'm substituting, 90 minus Y. That there becomes 90 plus Y because I've got 180 minus 90, and then I've got negative Y, which becomes positive Y. And that's actually the same as the expression I've got here. So that was another method. Obviously, you needed another reason, the triangle rule the straight line rule to back that up, but you could have come up with an alternate way to solve that question. So now moving on to question number 10. This is another merit question here. This one here had its challenges, but it was actually okay once you started applying the parallel line rules. So we're trying to find out W here, and the most obvious thing is to figure out, well, if I can find out this angle, they're all sitting on the straight line, and then I'm going to be sweet. But the problem is this angle here, you couldn't figure it out with the information you had. You needed some more information or to do a couple more steps to do that. So the first thing I did was I looked, well, I've got 58. Is there anything that's also going to be 58 degrees from that? And you can see your parallel lines here and here, and you've got your bisecting line. So that means this angle down here, that's alternate to 58 degrees. So that means that's going to be 58 degrees. So let's call that one Y. So we've got angle Y. So angle Y is going to be equal to 58 degrees, and that's because they are alternate angles. So let's write that reason out properly. Alternate angles in parallel lines are equal. Oh gosh, spelled parallel wrong there. So once you had that reason there, you then had to think, well, what else could I do with it? And I could actually figure out this angle here. Let's call this one here as X, because that there and that there, those lines there are the same length because they've got those little dashes there. So that actually tells us we have an isosceles triangle. So those two base angles there have to be the same. So that means that X is going to be equal to 58 degrees, and that's because we had base angles of an isosceles triangle are equal. And this is why this question is already one of the merit questions, because the two rules we're applying are a parallel line rule and probably one of the more complex year 9 rules. And then once we've got that, we can then go straight to W, and we can actually find out that using your triangle rule. Alternatively, you could calculate this angle at the top here because that's going to be alternate to X. And then you could apply the straight line rule there as well. So a few different methods from here, but let's go for the one-step method by going straight to W. So that means W is going to be equal to 180 degrees minus 58 again. This is the triangle rule in action. And when I did all of that, I got 64 degrees. And that there was angles in a triangle sum to 180 degrees. Right, we're now into question number 11, and 11 was the first of the excellence questions, so we know these are going to be challenging. So if you're ever worried about time in your exam, skip the excellence ones, do them at the end of the exam. Make sure you lock in all your merit, your achieved and merit marks first, because some of these are going to be time consuming. So the first thing to note is let's break through the question. So we've got a square. So we know that this here is a square. So the only thing that really tells us is we've got a bunch of right angles in the corners. And the way I navigate these three questions is I kind of put in the information as I read it. We've got the points A to F written on its edges, and you can kind of see those in the diagram there. There's D, there's C, there's A, you see all the other ones. We also know that points AC are the midpoints of the square side. So these here are exactly in the middle of the square. And we also know that AB is equal to AC, which is equal to AD. So all of these things are the same. So these here are all lines. So at this point here, it would make sense to draw in those lines. And this is why it's an excellence question, because you're kind of constructing the diagram yourself. So let's connect a line there. So my drawing is going to be not flash, but there's a line there. There's AC, and there's AD. And specifically, they told you these are all the same. So I know that, and that, and that. All of them are the exact same length. We've been asked to calculate angle ABE. Just a reminder, so we've got A down here, B down here, E down here. So we're trying to calculate this angle up here. That there is angle ABE. And we need to support our answer with geometric reasoning. So a lot of people fell into a bit of a trap here. And there's a few different ways we could have gone about it. So a lot of people thought this bottom triangle was going to be the key to solving it. And there was one method to do there that I might mention after this. But the trick to noticing this was, if you see line AC is the side of the square, isn't it? So that means line AC is the same as all four of the sides. So what that means is, I'm actually going to draw in an extra line. If I draw a line BD, so I'm going to connect a line here. Maybe I draw a dotted line here. So this is the one that I'm kind of constructing myself. So this line here, because it's the same as the side of the triangle, that's also going to be the same as line AC, which means it's going to be the same as line AD, and it's going to be the same as line AB. So that tells us this triangle here is an equilateral triangle. So that's the first step to this question, is communicating that there. So I guess the first step, let's do them in bullet points here. So we know that length AB is equal to AD, which is equal to AC, which means they are all equal to length B, or length BD, isn't it? Okay, so that's the first step. So I've talked about the relationship of the lines and all the lengths. Now that I've done that, I can now specifically talk about that triangle. So this means that triangle ABD, so just noting ABD, that's just the corners of the triangle, so people can know what I'm talking about, is an equilateral triangle. And because it's an equilateral triangle, that tells us some information about the internal angles, right? So it tells us that all three internal angles there, that's 60 degrees, that there is going to be 60 degrees, and that there is going to be 60 degrees. Okay, so that means angle ABD, that's this top angle here, is going to be equal to angle, let's do this one here, that's B, or ADB. And then is equal to that bottom angle there, that's BAD. So all of those are equal to each other, and all of them are equal to 60 degrees exactly. So that's the first step there. The next thing we need to figure out is we know that angle DBE, so that's this angle here, the one kind of coming up here, we know that those two lines are parallel. So so angle BDE is equal to 90 degrees. And that's because length BD is perpendicular, forgive my spelling, of perpendicular to length, what's that, BE. So that's what we've got there, and because we've got that, if this one is 60 degrees, that means this missing angle here down the bottom has got to be 30 degrees. So this means angle ABE, that's the one we're calculating, that's going to be 60 degrees minus, 90 degrees minus 60 degrees, and that there is going to be 30 degrees. And that there is just our arithmetic or our maths to solve that question. And I want to note there's a few other ways to do it. So because this line down here was the midpoint, you could also make a determination that this angle here is 30 degrees because it's symmetrical, it's chopping it up. That means this angle down here had to be 60 degrees for the same reason about the 90 degrees being perpendicular, which means you then could have figured out that top angle using the triangle rule. That's basically what we did here. They've just got that extra step involved, but it would have been the same maths with one extra layer of working, as I said, kind of sitting in between here, talking about the triangle. And the final question, question number 12, this is the last excellence question. It's the last question from section A in geometry. It's a bit of a long section, but just a reminder, your real one should be slightly shorter. So the way I want to solve this question here, I can firstly see we've got a clear regular polygon, and that's given to us in the question. It's told us it's a regular heptagon. If you didn't know what heptagon means 7 sides to a shape. We've been asked to calculate x, include all the reasoning. So the first thing to figure out is x kind of sits within that shape there. But that shape includes these angles here. So angle A, angle G, angle F, and angle E. And all of those are the same as angle B, C, and D. So I know all of the internal angles of my regular heptagon, including the 4 that are in the half of the shape that I'm curious about. All of them have to be the same. So I'm going to first apply my regular polygon rules to help me figure that out. So to find out the internal angles of a regular polygon, I need to find out the total internal angles. So the total internal angles is 180 n minus 2. And then I need to chop it up evenly into n number of sections. In this case, it's 7. So what I'm going to do is I'm going to take away the n's, put in 7, and that'll help me figure out each of these internal angles of that heptagon. So we've got 180. So there's 7 sides, so it'll be 7 minus 2 over 7. And when I do that on my calculator, I get 128.57 degrees, and I had a 2dp rounding. Just a note, I rounded to 2dp. You might have rounded to 128.6, even 129, maybe 3dp. That's all good. As long as you set your rounding, you're going to be fine. And my reasoning behind that really is angles inside a regular polygon are all equal. So that's the kind of the geometric property I'm relying on here. So angles in a regular polygon are equal. So that was my first step. Now that I've got that, I can move on to the second step, and that's then focusing on the 6-sided shape that I initially highlighted. And as I talked about, so you can see you've got 1 side down here, 2 sides, 3 sides, 4 sides, 5 sides, 6 sides. So there are 6 sides to that. So what I'm going to do here is I'm going to try to find out the sum of all of these angles. Because I know, well, that's 90 degrees there. So let's start by writing that by 90. That there was 128.57. That there is the same. That there is the same. And that there is the same. I actually know all of the angles inside the 6-sided shape apart from x. So I'm going to use a bit of subtraction once I figured out that number. So let's find out what that is. So total angles of 6-sided shape. And that's going to be the formula we applied before. So it's going to be 180 n minus 2. But I don't need to divide it by n here because I don't have equal angles here because it's not a regular shape. So that's going to be 180, 6 minus 2. And when I do that on the calculator, I get 720 degrees. So that tells us, or my reasoning to support this particular part, is angles in a 6-sided shape sum to 720 degrees. And now that I've got that, I can now calculate the actual angle x. And this kind of backs up the reason I've already got. So I've got the 720 degree total. I'm going to minus 4 of those 128.57 angles. It's because I got 4 of them on my diagram. So it's going to be 128.57 multiplied by 4. And then I also need to subtract that 90-degree angle from the very top, just up there. And when I do that, I've got my answer here, 115.72 degrees. And that reasoning I've got there really kind of supports that reasoning as well. So I don't need to back that up again. So that wraps up the geometry section. Hopefully from this, the key thing you want to take out is these reasons there. They're really, really important. If you don't have those, you're not really going to be able to get any success in these. I've got a whole bunch of reasons here. I can see reasons everywhere on this slide here. Some more reasons here and here, some over there as well. So make sure you stick to those reasons to maximize the marks you are getting. Under section B. Section B is the measurement and right angle triangle section of your exam. It is worth 20%. Which means you should be spending 20 minutes on it. The first 5 questions are multi-choice questions. Let's get straight into them. Question number 1, what is the volume of the given cube? This, I've written cube here actually. That should be cuboid, shouldn't it? So it's a bit of a typo. Hopefully some of you noticed that as well. And the volume of a cuboid is given to in your formula sheet, and it's base times height times length. And in this case, we've got a base of 5, we've got a height of 3, and we've got a length of 2. When you do all that math, you've got 5 times 3, that's 15, times 2 is going to get you to 30. This one's a bit tricky. We've actually got 230 as the option, so let's check out the details. This one here says centimeters squared, this one here says centimeter cubed, and because it's a volume question, and it kind of in the diagram, the volume is all about how many cubes can you fit in. So that means the answer there has got to be D. The answer to C, that would have been the area of something, but not the volume of this shape. So question number 2 is next. How long is the opposite side of the given right angle triangle? So this is kind of like a trigonometry type language. And hopefully your teacher told you about the 3 sides of triangles. You've got the hypotenuse, you've got the opposite, the adjacent. What we're going to do is I'm going to label my triangle to make my determination. So my hypotenuse, I'll start off with that. So there's the right angle down there, green dot. The opposite side to that is always the hypotenuse. You're always going to be given an angle. Or you're interested in an angle. So that given angle in our case is Q, and the opposite to that is the opposite. And then finally, in between the given angle and the right angle is always your adjacent. So in this case, we're looking for the opposite. So that's going to be that 13 centimeters up there. B is the answer to that one there. So moving on to question number 3, we've got calculate the perimeter of a regular hexagon. So regular tells us all of the sides are the same. Hexagon specifically tells you there's 6, and that matches the shape we got here. We know that the base of the shape is 7.5 centimeters. So that tells us this part here, that's the base, that's 7.5 centimeters. So to find the total perimeter, all we've got to do is times that by 6, and when you do that, you get 45 centimeters. So that there is option D. So we'll go straight to that one there. So on to number 4 now, which would correctly calculate the area of the given triangle. So here's our area there. Just a reminder, the area of a triangle is always 1/2 times base times height. That's in your formula sheet if you ever need to double check that in the exam. And I guess the first thing to note is the base of this triangle is 33. So anything without 33 in, we can just disregard. So we can see A, that doesn't have 33 in, so that's gone. The others all have 33. So that means they could all be valid answers. The next one is, this is a bit of a trick, this slanted side. A lot of people for some reason think the slanted side is the height because it's part of the triangle, but you're looking for the vertical height. So that means 21 is going to be the height. So we can have a look here. Option C, that doesn't have 21 in it at all, does it? So we can get rid of that there. So we're left with one of these 2 options here. These both have 21. So 1/2 times the base, which is 33, times the height of 21. That's the correct working. And that looks a little bit like option C, except it's been juggled around, right? We can see the 33, we can then see the 21, and then we can see the 19. So B looks like the best answer. It's got all of those put together for us. So now to question number 5, and this was actually the achieved mark for in terms of the multi-choice section. It was a bit of a tough one. What expression would represent the perimeter of a 3/4 circle? So I guess the first thing to note, perimeter is the outside of the shape, and the circumference is what that relates to. And remember, on the formula sheet, it tells you specifically that's 2 pi r. Don't be fooled into my pi r squared options, because pi r squared is the area. So straight away, I can see pi r squared in A and C. So that means I know those aren't my options. A and C are gone. The next part is I can actually see these are both the same thing here. And just to show you where that comes from, so 2 pi r was a full circle, and because we had 3/4 of a circle, we just go times by 3/4. So that's where that times 3/4 come from. So the only question is, this one doesn't have 2r, and this one does have 2r. So we just got to figure out which one is relevant for us. And that 2r represents this edge of my 3/4 circle, these two edges here, the two lots of the radius. So it is really important the perimeter did include those two radiuses. So we're going to need to be as, also D is going to be the option that we're looking for here, because we had the 3/4 curved edge. So that was the 3/4 part. And then we added on the two lots of the radius to find the total perimeter of that shape. So we've done that. We're now on to kind of the wordy, more problem-solving style questions where there's maths to do. So question number 6 is the first one here. You need to use trigonometry to answer the question below. And the question below has got us to say, well, there's find length AC, and AC is this part over here. Explain which trigonometry formula must be used. So I guess the first thing to note, this carries on from our multi-choice question. You need to label HOA first. Remember, your hypotenuse is always the opposite of the right angle, so that there is H. My given angle, 27, opposite to that is the opposite, and in between the right angle and the given angle is the adjacent. So we've now labeled the sides. Now, one of these two letters we don't actually care about. So obviously we care about this length here, the adjacent, because we've told it's 13 centimeters. We care about O, the opposite, because that's the question, that's the point of it, right? To find AC. That means H. We don't care about H because we don't have it and we don't care for it. So let's cross that out. We're left with two letters. And if you look at your formula sheet, there'll be a whole bunch of formulas, but basically they are sine angle equals opposite over adjacent. That's not relevant for us because you see how we've got O and A, so we're looking for the one that has the O and A letters. The next formula was cos angle equals A over H. Again, not relevant. And the final one, the one that's relevant for us, is the tan one. Tan equals O over A, because we're dealing with the O and the A side of the triangle. So we know that the tan formula is relevant. So we're just going to need to put that in a sentence, and ideally you want to mention the opposite and the adjacent as part of your answer. As we are calculating the opposite and are given the adjacent, we need to use the tan angle equals O over A formula. There you go. So to get full marks there, for the full achieve mark, you did need to mention the two sides of the triangle, and you did need to specifically say, I'm using this formula. So now on to question number 7. And this here is basically saying from the answer in question 6, so we've decided we need to use tan. They actually want us to go ahead and calculate length AC. So let's jot down the formula. So tan angle equals O over A. We can pull out the information that we need. So O is our unknown variable. So let's actually call that X. So we've then got X. So this O here is going to become X. So that's going to be X over 13 because A is the 13 side of it. And that needs to be equal to tan angle. And our angle is 27. So I've substituted all of those in. Tan 27. This here is just an algebraic solving question because X is what I need to know out. There's only one letter here. Remember, tan 27 is just a number, so don't stress about that. So the opposite of this the opposite of that divide 13 is times by 13. So that means X is going to be equal to 13 times by tan 27. Make sure your calculator is in the right mode because there is such a thing as a wrong trigonometry mode. And when I did that, I got 6.62 centimeters, and that there had a 2 dp rounding. If your answer is not 6.62 or some kind of number that's close to it, you're in the wrong setting. Check with your teacher how to change that before the exam. Definitely don't do it during because no one will be able to help you with that. So now to question number 8, calculate the volume of the prism below. So the volume of prism was something that was in the formula sheet. So volume of prism, and to do that you needed the area of the face, and then you need to times it by the depth. So the first thing we want to figure out is let's do a separate side calculation for the area. And we also need to identify the face. So the face of the shape is, we can see this kind of trapezium kind of going around here. I've highlighted in green. That's the face of the shape. And then it's been extended or dragged backwards because we've got some parallel lines happening as the picture goes back. So the face here is a trapezium. So we're going to need to find the area of this trapezium first. So the area is going to be A plus B over 2 times height. Again, that was from your formula sheet. A and B, so A is the top of your shape, B is the bottom of your shape, and the height is that 6 centimeters, the vertical height between the two parallel lines. So let's put that into our calculator. So we've got 5, which is A, plus 8, which is B, divided by 2, times by 6. If you are plugging this in the calculator, make sure there's a bracket wrapped around the top of that fraction, or else the calculator might get a bit confused. And when I did that, I had an area of 39 centimeters squared. Noting squared because I'm still on the area side of the calculation. Now that I've got that, I can substitute that into my formula up here. So I've now got the area of the face, which is going to be 39. So that will be equal to 39 times by the depth. What's the depth here? The depth is basically how far it's been dragged back. And in this case, we can see just up the top there, it's 3 centimeters. So 39 times 3. And that there gets me to 117 centimeters cubed, and that there is the volume of that trapezoid prism, whatever the technical word is. So question number 9 there. So if the face of the trapezium in question 8 is symmetrical, use Pythagoras' theory to determine the length of the face's slanted side. So let's draw a bit of a sketch. I'm going to redraw the face. And we were told, that height there was 6, that there was 5, and that there was 8. So what it's specifically referring to is this kind of little right angle triangle that gets created. Let's kind of blow that up a little bit. Let's draw that part there. So we know that's a right angle. We knew this bit here was the vertical height of 6. We've been asked to find, let's call that x. That's the slanted side. And the only issue is we don't have any information. So there's a few options here. It's a right angle triangle, so it could be trigonometry, unlikely because we don't have any information on angles, or it could be Pythagoras' theory. And Pythagoras' theory means we somehow need to figure out this bottom angle here, and that's when that symmetrical part comes into play. So going back to my trapezium, so the top is 5 and the bottom is 8, which means it's 3 centimeters bigger. So the bigger part, kind of this bit down here and this bit down here, those there must combine to be the extra 3 centimeters. And because it's symmetrical, we're going to chop that 3 centimeters in half, which tells us that side over there, that had to be 1.5 and that had to be 1.5, which means the bottom of the triangle there that we're dealing with, that there had to be 1.5. Now that I've pulled that out, I can apply my Pythagoras' theory formula. I've taught my class a bit of a shortcut. So because we're doing a long side calculation, we need to add together these two squares. So we've got 1.5 squared plus 6 squared. And that will tell us how big the square is on this side here. And to find the length, we have to then do its square root, which is why I have a square root there. And when I do all of that, I get 6.2 centimeters, 1 dp. And that there was a bit of a rough achieve mark, but because it's Pythagoras' theory, that's a year 9 skill. We can't just give you marks for any old right angle triangle Pythagoras' theory question. There's got to be a little bit extra work to it, and the use of symmetry and getting the base of 1.5 was the extra work there. So we're now on to question number 10. Calculate the area of this isosceles triangle. And isosceles triangles are really nice because you can always chop them in half. So let's chop it down this way here. Chop it in half. And when you chop it in half, you create two right angles here and here. And that right angle there is going to be really important because that will give us the vertical height of the triangle, that squiggly line there. And that's really, really important because you need that to find the area of a triangle, right? Because the area of a triangle is equal to 1/2 of base times height. And as it stands, we've got the base of the triangle, which is 9, but these 7s, they're not the height of the triangle. So we can't actually use those for that height part of the formula. So because I've broken into the right angle triangle, I know that the base of this smaller one is going to be 4.5, which is half of 9. So I've used the same symmetry kind of thing I used in the previous question. And that means if I call this one h up here, I can now find the height of this triangle. So let's find the height first. So the height will be equal to, and because I'm finding the short side of one of these triangles, short starts with S and so does subtraction, I've got to be subtracting the two squares, 4.5 and 7. So we're going to go square root of 7 squared minus 4.5 squared. And plugging that into my calculator, I get 5.36 centimeters, and that they had a 2 dp rounding. And I like this answer here because, remember, 7 centimeters was the longer side of the triangle, so the answer had to be less than 7. So I know I haven't stuffed it up at this stage. If I got an answer more than 7, I know I would have stuffed it up. Now that I've got that, I can now use that as part of my area formula, because don't forget that there is 5.36. I've now got the base of the triangle, which is the full 9, and I've got the height of the triangle, which is the 5.36. So my area is going to be equal to 1/2 times by the base of 9 times by the height of 5.36. And when I put that in my calculator, I'll get the answer, and that there was 24.12 centimeters squared. And I got my units centimeters squared there as well. So the next question, this one here is a bit messy as well. From the diagram in question 10, which I've drawn all over, but I'll redraw it, calculate angle CDE. And just to note, angle CDE, C was over here, D was here, E was here. That means we're trying to find out this angle over here. So what I'm going to do is I'm actually just going to sketch out the right-hand side of this isosceles triangle. So let's do it over here where I've got a bit more space. So that was the middle. So let's say that there is C now, that there is D, and that there is E. I'm trying to find out this angle here. That's my unknown angle. I'll put the unknown angle symbol in here. That's my unknown angle. I knew that was 90 degrees, and I've got some information on the sides. I've already know this to be 5.36, and I know that the bottom is going to be 5.3. So what I'm actually going to do here is I'm going to use my inverse trigonometry, and that's why it's actually a merit question here, because this inverse trig stuff is quite difficult. So let's start by labeling the sides, and again, it's like my other questions. I need my H, my O, and the A. So my hypotenuse is over here, and I don't care about that side because I've got these two here, right? So straight away, I know it's going to be tan because of the TOA. So that's my given angle there. There's the opposite, which means in between the right angle and the given angle has to be the adjacent. So that kind of confirms it's tan for TOA. So we've got tan angle equals O over A. Remember, I'm trying to calculate the angle here. So that's going to stay as my unknown, and I can substitute in O and H here. So O was 5.36 based on my previous question. A was 4.5. So that means tan angle is equal to 5.36 over 4.5. And this is still algebraic thinking here because this is a formula. So we need to get the angle by itself, which means this tan needs to move to the other side. And hopefully remember, the opposite of a tan is the tan minus 1. So that means the unknown angle will be equal to tan minus 1. And then put this in brackets. So it's going to be 5.36 over 4.5. And if your calculator's in the right mode, again, your calculator might be in the wrong mode. I'm getting 50 degrees. So we're now to question number 12. This is the first of the excellence questions, and this one here, there's nothing particularly tricky about it, but it's you've got to be insightful with your use of algebra to get this. So let's break down the question. So the square base pyramid below has a surface area of 160 centimeters, so they've told us the area. The square base is 8 by 8 centimeters, and we've been asked to calculate H. So it looks like H is the vertical height of one of the side triangles, and because we're dealing with the surface area, if we write down the square base and, put down the 4 triangles, so each of the 4 sides, we're going to kind of collapse them down. We know that the shaded area, if I shade in the whole lot, the shaded area of all of that is going to be 160. So I can set up a bit of a formula with that. So I know that the surface area of this pyramid is going to be equal to the area of the square plus 4 times the area of the triangle. So we're just going to find out one triangle. And this triangle formula here, remember, that's going to be 1/2 of base times height. And that height is what you're going to be using algebra to work for. So we should be able to figure out everything else in this formula apart from the H in the triangle formula. And then we can use some algebra to work backwards to find this. So let's keep going with this. So the surface area we already know is going to be 160, right? So the surface area 160 will be equal to the area of the square. So the square is just going to be base times height, which is almost given to us in the question, 8 times 8. So that's going to be 64 plus the area of the triangle, so 4 times the area of a triangle. And remember, the triangle is 1/2 of base times height. I can now continue with this working, so it's going to be 160 will be equal to 64 plus 4 times 1/2 times the base. The base of one of these triangles there is actually the same as the side of the square, so it's going to be 8 times by the height, which is what I don't know. And if you have a look at this here, this is just an equation, and there's only one letter, so that means you should be able to use some solving strategies to go ahead and calculate that. So before we start the solving bit of it, let's simplify all of this mess here. So I suppose let's do the first timesing first. So 4 times 1/2 is 2, and then times by 8 is 16. So all of that there is going to become 16h. So that there is going to be 160 is equal to 64 plus 16h. I can now solve this here. I can do minus 64 to both sides. So I've got 96 is equal to 16h. I can then go divide by 16 to both sides. And forgive me, that's where my pause button is, so I'll move to the side. That means h here is equal to 6 centimeters. So pretty rough, you got to be pretty insightful to set up that equation initially, but once you get there, the algebra to solve the problem of getting h as 6 isn't particularly tricky. So we're now on to question number 13. This one is tricky. I won't sugarcoat that one, so this is definitely the hard excellence question of this exam. So we've got triangle ABC as a right angle triangle. So you've got triangle ABC, I've drawn that in the diagram. You've even got the right angle part drawn there. The three corners touch the circumference of the circle. So these three corners here are on the circle's edge. Length AC is 10 centimeters, so AC is the one going here. So we know that there is 10, so let's write that in. And that's useful because if we need to do, because it's a right angle triangle, if we need to use Pythagoras' theory or trigonometry, we've got one of the sides to be able to use as an input. And it goes through the circle center. So going through the circle center means AC is actually the diameter, which is 10 centimeters. So that means the radius for this triangle is going to be half of that, 5 centimeters. And that's going to be important, the radius, because if I need, to find the perimeter of the circle, the circumference, if I need to find the area of the circle again, I need that radius number instead. And we'd also been told the angle ACB, so we've got ACB, so it's going to be this angle here. I've been told that's 35 degrees. Calculate the shaded portion of the circle. That's what we're aiming for now. So I guess if we start the question like we have in the previous bit here, the shaded area is going to be equal to the area of the circle minus the area of the triangle. So that's kind of a general way I like to start these measurement ones here. The area of the circle is going to be easy to figure out. That's pi r squared, and we've got the radius, so there's nothing wrong there. The triangle's where the big problem is, because you've got to find, it's 1/2 of base times height, right? So you've got to find the base of the shape, which is AB. We weren't told that. And we've also got to find the height of the shape. We weren't told that either. However, because we've got a side and an angle, we can actually use trigonometry to find out the other two here. So let's start off with the side over here. Let's call that one there x. So let's calculate x first. So if we're dealing with x, we know that, this side over here, that's the hypotenuse. Hopefully the pen draws up. There it is, h. This side here is the opposite, and that one there is the adjacent. So by using those letters, we are interested in these two sides of the triangle, so we're going to be using sine. So we can use sine to get x. So sine angle is equal to O over h. The angle is 35, so that sine angle is going to become sine 35. The opposite is x, and h is 10. So that means x is going to be equal to 10 times sine 35. And then don't forget that times 10 is there because that's the opposite of the divide by 10 from above. And when you put that into your calculator, make sure you're in the right mode, because sometimes there are some issues with the calculator settings here. Actually, it's bad working to go
across the page there. So let's go x is equal to 5.74 was what I got when I did that on my calculator earlier. We can now repeat this process. So we know x, so I've rubbed that out. We can now calculate y, which is the one going along the bottom. So let's get the green pen back. That there is y. So we're going to use trigonometry again to find y. So that's still the hypotenuse, that's still the opposite, that's still the adjacent. This time around, we're not interested in O, so we're trying to find the hypotenuse and the adjacent, and that there is our cosine formula. So we know that cos angle is equal to A over H. The angle is still 35, so that's cos 35 is equal to A of y, and then H of 10. Same thing as last time, that divided by 10 becomes a times 10. So that's 10 times cos 35, and we can put that into our calculator, and when I do that, I got 8.19 centimeters, and that also had a 2 dp rounding. So now that I've got that, I've actually got the information I need. So remember how I talked about the area of the triangle being 1/2 of base times height? We can now actually go ahead and do that. So let's carry on with that working there. So my circle area was pi r squared, so that's going to be pi times 5 squared, and I needed to subtract the area of the triangle, which was 1/2 times base times height. So 1/2 times the base, and the base was y, which was 8.19, and the height was x, which was 5.74. So this is almost the easy part, right? That seemed a bit effortless to do that. Now that I've done all that timesing, I'm plugging it into the calculator exactly as it is. I'm getting 54.14 centimeters squared, and that there had a 2 dp rounding. Okay, so we're now into the big section, Algebra 1, 40% of your exam. So because it's 40%, you should be aiming to spend 40 minutes on it. The first 6 questions are multi-choice. And question number 1 is where we're going to start here. Which of the following expressions is not equivalent to the others? So I love putting these questions in, and the trick to this is basically just to quickly simplify each section, each question. So the first one there, that's going to just become 3a, because we got 6 divided by 2 just becomes 3. This one here is even easier. We can just get rid of those time signs. This one here is even nicer. There's 3 ABs. And this one here, we can't actually simplify that because we can't put together an A and a B. So D is the answer, because that A and B can't be combined to get the AB like all the other ones have. Okay, we're now on to question number 2. Number 2 is, we put this in because it's a really common math error that we see every single year, even up to year 12 calculus. Substitute that. So when you're substituting in a negative number for this A squared here, you need to put negative numbers in brackets when you sub them in. So your working really here should have been negative 12 bracket squared. And when you put that into your calculator, you get 144. A lot of people do negative 12 squared. And what this means is the calculator does the 12 squared first, which is 144. And then it deals with the minus sign afterwards, and it just shoves it up front. So that there is wrong. And that positive answer B would have been correct. So on to 3, which of the following would be the best first step to solve this question here? So there's a few different ways you can actually solve this question. So we're looking for the best one here. The first option says add 2 to both sides. So if we add 2 to both sides like that, that doesn't work because this 2 here is locked away in a bracket. So that's not a good step. It's a good step to get the wrong answer, but not the right one. Expanding the bracket, so you could do that times that, which would be 15x, and that times that, which is negative 6x. I actually quite like that step. I think that's the right answer, but I'm just going to check the other ones there. Divide both sides by 5. So same logic as A. That 5 is currently locked away in the bracket, so I can't do anything with that yet, so that's definitely the wrong answer. And then finally, I've got multiply both sides by 3. And that there's a bit of a trick one to make you think that getting rid of the 3 is the first option. If you were to get rid of that 3, you could have divided both sides by 3. But multiplying both sides by 3 just turns that into a 9 and turned that into an 18. So you haven't actually done anything productive. You just made the numbers bigger and potentially worse to deal with. So I like that. So let's circle B. B was definitely the right answer. Expanding the brackets was the best first step there. An alternate approach would have been dividing both sides by 3. So question number 4. Below are houses made from matchsticks. How many matchsticks would be needed to make a pattern with 5 houses? So that would be, this one here plus 2 more houses like that. So let's kind of think about the pattern, explore the differences, and come up with the answer. So this first one here, we got 1 here, 2, 3, 4, 5, 6. So this pattern here, 6 houses. And if you think, that one there, that was the first house, right? Which is 6. So we then got 7, 8, 9, 10, 11. So that there's got 11. I can see I've got a difference of 5. And that makes sense because it's that extra house at the end. I'll highlight it on there. There's 1, 2, 3, 4, 5. Every time we're adding on an extra house, which is 5, because we've already got that kind of conjoining wall there. So that means this one here must be 16. Noting the questions asked us about the 5th house. So if you had 4 houses, that there would have been 21. And if you had 5 houses, that there would have been 26. Because I've carried on, I've added 5 on to both times. Hoping that's one of my options, and it is. Option B is the answer to that one. So now on to question number 5. If the given point has been moved, we'll underline it, down 1, left 4, what is the coordinates of the new point? So let's just sketch on the new point and see where it lands. So we're going to go down 1 over to here, and then we're going to go left 4, which is over here. And that new point there would be, remember it goes x, comma, y. So I need to find the x number first, so that there will be the negative 2. So it'll be negative 2, comma, negative 1. And hoping again that's the option, and that there's option C in this case. Now into option D. Which of the following statements about straight line graphs is true? So that means 3 of these statements are going to be incorrect. There's going to be some issue with it, and 1 of them is going to be true. So the gradient of the straight line can be calculated by run over rise. We know that's wrong because if you look at the formula sheet, it's rise over run. So that there is a wrong answer. So no, that's not going to be the one I'm circling. The x-intercept of the straight line is when x is equal to 0. I'll draw a bit of a sketch to explain why that one's wrong. So an x-intercept would be here. But an x-intercept could be anywhere on the x-axis. So that means x isn't always going to be equal to 0. But if we go back, the reason I tried to trick you with that question is if we go back to the y-axis, it's always 0 for the y value. So that means at the x-intercept, y must always be 0. So I know that one there is false as well. The same thing here, y-intercept, y equals 0. So at the y-intercept, x must be 0. So I know that one there is wrong. And then finally, the equation of the straight line graph tells us about the gradient and the y-intercept, and that there is the correct answer, because let's just make up an equation here. Y equals 3x plus 2. That's a nice straight line. Plus 2 is the y-intercept, and 3 is the gradient. So the equation of a graph tells us about those 2 things, which means I'm going to circle D as my answer. So we're now onto the skills kind of section, and we're forming some expressions here. Let's start with 7. Form an expression for the given scenario. Let n be the unknown number. So in these questions, I'll be telling you what the letter is. So don't just pick a random letter. Read the question properly. Pull out that letter. So 10 is decreased by an unknown number. So for example, let's say 10 is increased by 2. You would have done 10 minus 2 equals to 8, right? Obviously, we don't know what the minus 2 is here because it's n. So in this case here, it will be 10 minus n. A pretty popular wrong answer here is people, I imagine, would have wrote n minus 10, but you wouldn't be able to do that. Okay, we're on to 8. Form an expression for the given scenario. Let A be the first unknown number. Let B be the second unknown number. So the product, that's a new word potentially, the product of the first unknown number and the second unknown number is tripled. So I know tripled, I know something's going to be times by 3. And the word product means timesing. So what it's going to say, this question saying, is it's saying we're doing A times B, so that's going to be AB, and then we're multiplying it by 3 by putting the 3 out front. So now moving on to 9, we're into another achieved question. Form an expression for the scenario. Let X be the unknown number. Your expression must be simplified. An unknown number is doubled, then increased by itself, and then reduced by 3. So an unknown number is doubled. That bit's easy to deal with. That's going to be 2x. And then it says it's increased by itself. So that means we're adding on itself. So we're adding on another x. And then reduced by 3 minus 3. So that there would get you a developing mark because the questions clearly ask you to simplify. So we can group these x's together here. If you simplified that there is going to be 3x minus 3. So now into question number 10. Straight away, I'm seeing a whole bunch of words and a bit of a mess here, so I know it's going to be a merit question for this one here. So Mr. Bowden is bringing in 2 bags of lollies, each with an unknown number of lollies in. So L is the letter that's going to be part of an algebraic expression here. Before class, Mr. Bowden eats 3 of them. He then shares the rest amongst the 12 students present. Form an expression for the number of lollies given to each student. I suppose the first thing to start is the top of the sentence there. He's got 2 bags. So that there is going to be 2 times L, so 2L. Now, from the 2 bags, he's opened them up, he's eaten 3. So he's eaten 3. So 2L, and we're going to go minus 3, whatever that is. And then following that, he's shared the remaining amongst 12 students present. That was a bit of a tongue twister, but that's basically division, that part there. So we're going to then go divided by 12. So I've made mine look like a fraction. If you're using a division sign instead, make sure your 2L minus 3 is in brackets, because remember, these fractions have invisible brackets on it. So if you're doing division, you need to make sure those brackets go from invisible to visible. So we're now to question number 11, and we've been told to use our substitution skills here. So a person's internet bill can be calculated using this equation here. So we've got an equation here where G is the number of gigabytes used in a period. Find the cost if 45.7 gigabytes are used. So let's jot down my formula. So the cost is equal to 0.5 G plus 50. So the crux of this issue is I'm going to substitute out the G. So the G is going, the 45.7 needs to go in its place. So that there is going to become 0.5 times by 45.7, and then after that I add 15. I'm putting that into my calculator. There's no tricks for that, but when I do that, I'm getting $37.85. So moving on to question number 12. It looks messy, this question, but it's actually quite cruisy, but it does look a bit messy. So a small object has kinetic energy of 200 joules and a mass of 5 kilograms. Use the formula to calculate the speed of V. So this is a merit question because it's got a square root in that, and that's just a high level skill that comes in. Roots and powers are a bit more prevalent in the year 11 curriculum. And we basically know what V is, right? So we know V will be equal to E and M. We did some other maths around it, and we know what those are both in the formula. So let's sub them both in. So I know that the top there, so it's going to become the square root of 200 times 2. So, and then that's going to be over 5. And simplifying that a little bit, so that's going to become 400 over 5. We're going to do the maths inside the square root first. That there is 80. So square root of 80 is 8.944, and that there had a 3dp rounding. So now on to question number 13, and this is the beginning of kind of big section where you've got to show a mixture of skills. You're expanding, factorizing, simplifying, and solving skills are all there. Just to note, if you are solving, remember you've got to include your opposites in your algebra. You can't just kind of mentally figure it out. Okay, so the first question here, I just want to note, this looks a bit mean for a developing question, but there's no powers anywhere. So typically it has to be a bit complicated or has some kind of power element to the question for it to be in the year 10 curriculum. So let's start off with the P. So we've got 3P and then we've got minus 4P. So that's going to be negative P. I can then deal with the numbers. I've got 7 plus 5. So that's going to be plus 12 over there. On to 14. We're multiplying here. So we start by multiplying by always doing the numbers together. So 10 times negative 3 is negative 30. And then B is the only letter here. So I'm just going to kind of take the B on, knowing that there's nothing else to do with that. So 15, we're now on to solving. So these two-step questions are from the Year 9 curriculum. So you must show, there must be some kind of bracket or 2 letters for it to then hit in the Year 10 curriculum. So we're going to start this question by doing a minus 2 to both sides. So we've got 6y is equal to 24. We're then doing divide by 6. So that means y is equal to 4. Now this question here, we can see it looks a bit messier. That it's just 2 double expanding questions, but because you've got to simplify them afterwards, that makes it a bit more difficult. So let's start that process, I suppose. So we're going to start off by doing that times that. That's going to be 25x. I call this the rainbow method. Hopefully you can see why. That times that. That's 35y. And then we've got that times that. That's plus 10. and then we've got that times that minus 8y. So if you get that part there, that's your achieved mark, because that's just basic expanding. But if you can go ahead and simplify that, you're going to lock in and get your mark overall, your full mark. So we've got the x's over there and there that they can be merged together, right? So 25 minus 8 is 17. So my final answer here is going to be 17x plus 35y plus 10. So now on to question number 17. That times that there is going to be 10xy, and then we've got that times that minus 4. That's where the 2 times 2 comes from. We now deal with the letters because there's actually a few letters alphabetically. We've only got 1x, so that's easier. And then we've got y times y squared, that's 3y's. That's going to become y to the power of 3. So question number 18. This is similar to the first one that was developing. It's now achieved because you've got powers everywhere. You can see the 2's and the 3's in the power spots. And I can only merge together these letters of these things if they have the same number and same power. So same letter, same power. So I can see the x cubed, they can be merged together, and the x squareds, they can be merged together as well. So let's do the cubes first. So we've got 8 cubed minus 1 cubed. That's going to be 7x cubed. And then we can deal with the squares first. We've got 2 of the squares here, minus 4 there. That's going to become minus 2, isn't it? So let's actually get rid of that plus sign and put in a minus 2x squared. I'm now on the number 19. This is all timesing. We can see times. You start off with these big messy timesing questions by dealing with the numbers first. So you've got negative 2 times negative 4 is 8, times 5 is 40. So that's the beginning of my answer here. That's going to be 40. I then deal with the letters in alphabetical order. So I've got a times a squared. So that's 4 a's in total. So that's going to become a to the power of 4. I then deal with the b's. I've got b times 3b's times 1b. That's 5b's in total. That's going to be b to the power of 5. So question number 20. This one looks a bit rough, but same thing. It's division, fractions, powers. So that kind of makes it an achieved one here. Always start off with the numbers. We got 12 divided by 63. 14 divided by 63. That division doesn't work. We can't actually do that division. So when you can't do the division, you've got to simplify the fraction. And 14 over 63, you can put that into your calculator, but I know they've both got a 7 involved. So if I divide the top and the bottom by 7, that's going to get me 2 over 9. So on the top of my fraction, there's going to be a 2. On the bottom of my fraction, there's going to be a 9. Like multiplication, I'm going to deal with all the letters alphabetically. So I can see there's an A on the top there, but there's no A on the bottom. So that means I can just put the A on the top there. I don't need to simplify that. Now dealing with the B's, I've got a B squared on the top and a B cubed on the bottom. I always think myself, if it's the top team versus the bottom team, who's got more B's? The bottom team's got more B's, right? How many extra do they have? They've got 1 B more. So that means I'm going to put 1 B on the bottom. And then the same with the C, I've got 4 on the top, 2 on the bottom. So the top has more C's. Specifically, they've got 2 more C's. So that there is going to become C squared. And if you can do that, that will get you your mark. Question 21, we've been asked to factorize this one here. Factorizing is all about identifying the highest common factor, and it's a bit tricky here, so let's look at all the letters. So let's start off with the numbers, then each letter. So the letters 6 and 21, they don't have much in common, but they are both from the 3 times tables. So that means the beginning of my answer, I need to take out a 3 from the bracket. Then we're dealing with the S's. We can see there's 1 S here and 2 S's here, so they've got 1 S in common. And then you've got 2 T's there, 1 T there. That means they've got 1 T in common. So we're going to put that there. So 3ST is the highest common factor. So now that I pull that out, I need to divide that there by 3ST. So both are going to be divided by, and that'll help me figure out, what goes inside the brackets. So doing the first bit first, we do the numbers. We've got 3 divided by 6 is going to be 2. S divided by S, well, the S's cancel each other out. And then you've got T squared divided by T. That's just going to become T. Then the next step, we've got, we'll just keep the minus sign there because that's unchanged. Then we've got 21 divided by 3 is 7. We've got S squared divided by S is S. And then you've got T divided by T. It cancels out. So we can close our bracket there. So that's a bit of a rough one. If you do need any further help in factorizing, because it normally is the hardest skill in this kind of algebra section, maybe let me know in the comments and I can reply with a video that breaks this down in a bit more detail for you. Merit question all of a sudden, same thing with factorizing. Remember, that's the opposite of expanding. That's why the brackets are back in the previous question. Looks like a bit of a headache. The answer to this one is there'll be a bracket, something outside the bracket, and there's going to be 3 bits in the bracket representing the 3 parts here. So the previous one had 2, this one's got 3. That's why this one here is a merit question. So dealing with the numbers first, 10, 60, 45, all of those are from the 5 times table. So they're all going to have a 5 in common. I can now deal with the letters M, and I've tried to muddle these ones around here just to confuse you. So I've got M cubed, and M. So that means they've only got 1 M in common. So it's the smallest amount of M's. I've now got N squared, N, and N. So they've only got 1 N in common. Now I'm going to divide each part by my 5mm, my common factor, to see what's left over. And these are my brackets. So divide by 5mn. So we've got 10 divided by 5 is 2. M cubed divided by M is M squared. And then we've got N squared divided by N is N. I'm now going to put a plus sign there representing that plus sign there. I've now got 60 nm squared divided by 5mn. So I've got 60 divided by 5 is 12. I might be running out of room here. N divided by N is gone, and we've got M cubed divided by M is M squared. I can now get another plus sign. Last thing, divide it by 5mn. I've got 45 divided by 5 is 9. M divided by M cancel each other out. N divided by N also cancel each other out. And then we've got our answer. And just so you know, if you're ever not sure you factorized right, if you expand this, so that times that, that times that, that times that, that should get you back to your answer. So you can always double check your answer mid-exam if you want to be sure to make sure your mark's locked in. So now to question number 23. This is a solving question. And because it's a fraction, that kind of puts it a bit harder than normal. You've got to know there's invisible brackets up the top here. So we can't get into that 4. Normally you'll get rid of the plussing first, but here we can't. It's locked away, so we've got to unlock the fraction by doing the opposite of division. And the opposite of division is timesing. So I'm going to go times 5 to both sides. So those 5s would cancel each other out, leaving me with x plus 4. That is equal to negative 10. I'm then going to do a minus 4 to both sides. So x is equal to negative 14. Again, this one here is achieved solving. We've got 2 letters. So that's what brings it up to a high level of the curriculum. So we've got 3x and 7x. I always target the smallest x's to simplify first. And then once I've simplified, I can then do all my opposites. So the smallest there is 3x. To get rid of that, I got to do minus. I'm just going to write, I'm writing the wrong answer here. A lot of people very commonly write minus 3. But just a reminder, 3x minus 3 doesn't get rid of the 3x. That actually just makes that minus 23 there. So you've got to be minusing 3x there. And I'll do the same on the other side. So that's going to become 4x is equal to negative 20. And then you go divide by 4. This is where your opposites can kick in now that you're simplified. X is equal to negative 5. We've got a merit solving question here. So the trick with this one, or these ones, you've got bracket equals something to do with the bracket. I would expand everything first using my expanding rules. So that's going to become 12x minus 40 for that side there. And then we've got 9x minus 3 on this side here. Now this question has 2 letters like the previous one. So I'm going to target the smallest of them by getting rid of it. So that 9x, I'm going to get rid of that by doing minus 9x to both sides. So that means 3x minus 40 is going to be equal to negative 3. And then I can get rid of that plus 40. So I get rid of the minus 40 by doing plus 40. So we've got plus 40 to both sides. So we've got 3x is equal to 37. And then I can do divide by 3, x is equal to. 37 can't be divided by 3. You can either put it into the decimal or you can leave it into the fraction. I'll leave it as a fraction, 37 over 3. But if you did get something like 12.3 recurring, that there would get you full marks as well. That's no stress. So now moving on to the next chunk. This here is when you have to form an equation from the scenario, and then you've got to solve it. And you've got to include your algebraic thinking, your opposites, as you're doing that. So a plumber has a call-out fee, a $40 call-out fee plus $25 per hour each. So that there, $25 per hour, that's your variable, right? Because that could change. So that's where your letter is going to be. The total bill came to $365. Form and solve an equation for how many hours the plumber worked. So I know my equation. That's that $25 number. that's going to be dependent on the number of hours. That's going to be 25 times by the number of hours the plumber works. He's then adding on his $40 call-out fee, because that call-out fee gets applied regardless of how much or how many hours he's there. And that's fixed. The $40 fee doesn't change either. And that there is going to be equal to the total of 365. So form the equation. That's your developing mark. If you can go ahead and solve it, even though it's a two-step kind of year 9 question, because it came from context, it made it harder. And that's why we can get our marks there. So we do minus 40 to both sides first. So 25h is equal to 345, or to 325. And the opposite of that 25 is divide by 25, which means h is equal to 13 hours. So we're now on to question number 27. And this one here, it's a bit different. It's from a measurement context, but you should still be able to figure out. So we've got an equilateral triangle. We can actually sketch that here to help us. So we know equilateral triangle, all three sides are the same. One of the sides is 2x plus 1. And I just want to note, if one side is 2x plus 1, all of them are going to be 2x plus 1. We know that the total perimeter of the shape is 39 centimeters. We've been asked to find or form an equation and determine the length of one of the triangle sides. So how long is one of these sides here? So I guess we've got to set up our equation first, and this one's quite straightforward. So one side is 2x plus 1, and we've got three sides, so we're just going to put that in a bracket. And we know that there comes to 39. There's two ways you could solve it at this step here. You could either expand, or you could go divide by 3 to get rid of that 3. Both will get you the same and full marks. Let's do the division approach here. Let's go divide by 3 to both sides. So that would cancel out that. That will leave me with 2x plus 1 over here equals to 13. And if you're clever, you would have noted you can actually stop here if you are clever, because 2x plus 1 is one of the sides. So straight away we know that the answer is 13. But let's carry on just for argument's sake. So we've got minus 1, 2x is equal to 12. And then you've got divide by 2, x is equal to 6. So we know that x is equal to 6. So what that means is if we substitute x back into the side formula, we're going to calculate how long that side is. So let's do that over here. So 2x plus 1, that's equal to 2 times 6 plus 1, which is equal to 13 centimeters. And that was the 13 that we saw up there, so that's why we could have stopped at that point. But yeah, that was just tricky. So if you expanded it, you wouldn't have seen this line here, so you wouldn't have been able to stop there, but you still would have solved like I did to get x equals 6. On to question number 28, and this is certainly one of the harder excellence questions in the exam. Just because it's so wordy, it's going to take a lot of attention to detail and maybe rereading this a few times to break it down. So we've got David and Harry. So the way I did this one was, because I knew there was heaps and heaps of information on each, I actually just wrote a list. So information I knew about David, and information I used or knew about Harry. And I do this list when I'm trying to do these big messy problems. I just write a list of all the information I know, and then once I've got that list, I can then, basically ignore all this and just focus on the core information, the core numbers that I've got. So David currently has savings of $780. So let's write that on David's list. So he's got savings of $780. However, Harry only has $15. So we can write that down here. So that means Harry's only got savings of $15. David can save $20 per week. So we'll write down 20 per week. And Harry can save $25 per week. Okay, so we've got $25 per week. And then finally, Harry's dad is worried that he won't be able to save enough and has offered to match whatever Harry saves. So that basically means he's going to double Harry's money, right? So dad 2 times 2 money. Okay, so read up to that. And then this is the rest of the questionnaire. After how many weeks will David and Harry have the same amount of savings towards the running trip? To be awarded full marks, you must form an equation and show full working. So the reason this part is in the question is because this is all about forming the equation. We don't want you just doing a table, calculating it, and eventually getting the right answer. And I did pick quite a big number, so that means if you did that, it would take you quite a long time to get there. So let's form the equation first. So let's figure out an equation for David's savings. And the unknown variable for us is the number of weeks. So let's call that W. So that means David can save $20 per week. So that's going to be 20W. And we're going to add on the current savings he has, which is 780. Harry's doing the same. So Harry's saving $25 per week, so a little bit more. So he'll slowly catch up to David, and plus his $15 of current savings. And because his dad is doubling it, we're going to put that in a bracket, and we're going to times it by 2. So a bit messy, this one here, but we're definitely going to run out of room for working, so I'll try to move the side of the page. And this here is now just an equation. So let's start by getting rid of the brackets. So it's going to be 20W plus 780. That's going to be equal to 50W plus 30. I can now solve this here by doing the minus 30. So if I move that 30 to the other side, that's going to be 750, right? So we're going to go minus 30 to both sides. Minus 30, minus 30. I can also simplify the W at the same time, right? I can move that W to the other side. So I'm going to go minus 20W. Okay, so those cancel and those cancel. So that means 750 we got a 30W. Oh, I don't think I'll run out of room now, which is good. But now I can get rid of that there by doing divide by 30, divide by 30. So that means W is equal to 25. So that means it'll take 25 weeks for Harry's savings to match David's savings. Okay, we're now onto the graph stuff, and we've been asked to use our pattern, graph, or table skills to answer these questions. So there are a few different ways you can answer these questions. And ultimately it is algebra, so some of those algebra simplifying, solving, all that sort of stuff, those skills might be relevant here as well. So with reference to the lines below, answer the given sub-questions. That's these sub-questions here. Which line has a negative gradient? So negative gradient is the one going downhill, so that's going down, that's going up a bit slowly. So that means line A is the only one with a negative gradient. We've then been asked what's the gradient of line B. So for line B, I always start off with the y-intercept because that's normally the easiest point to find out. And then I follow the y-intercept across until I see another point clearly. And I can see one up there, and I'll highlight that. So I can see those 2 points clearly. I then form a triangle. So that's my run, that's my rise. And that's because the gradient is always rise over run, isn't it? So if you've got rise over run. So my rise of this triangle was 1, my run was 4. So that means my gradient was 1 over 4. You could have written that as a decimal 0.25. But you didn't need to do that last step. What is the x-intercept of line C? So line C is the blue line. The x-intercept is over here at 6. Well, that's 8, isn't it? State your answer in a coordinate form. So remember, coordinate form means it's x, comma, y. So I know my x-intercept is 8. And my y-intercept, if I go back to my y-axis, my y value, that's just 0 there. And then finally, state the y-intercept of line A. Line A is all the way up here. Again, it's x, comma, y. X is 0, y is 4. X is 0 because if you go back to the x-axis, you've got 0. Okay, we're now to question number 30. State the gradient and the y-intercept of the line, and then we've got the equation there, y equals negative x plus 3. So the hardest part of this question here is spotting the gradient, because the gradient is normally the number that's in front of the x, and all we've got here is a minus sign. So if you remember from your simplifying expressions, so for example, 1x just becomes x, right? So that means minus x is just minus 1x. So that means our gradient there would have been minus 1. The y-intercept is super cruisy. Remember, the y-intercept is a point, a coordinate. So make sure you state it in coordinate form. And it's going to be 0, 3 because 3 was where it would hit the y-axis and 0 is the relative x point at that coordinate. So now on to 31. Show that lines A and B intersect when x is equal to 0.8. Start your answer by stating the equation of both lines. So let's state those equations. So let's make some room. So we'll write line A over here and we'll write line B over here. So line A is the red one over here. We know the y-intercept of 4. So that's going to be a first part. So if you're thinking of the equation y equals mx plus c, maybe I'll write it down here. Y equals mx plus c. I know that c is going to be equal to 4 for the red line. Now talking about the gradient, tracking this way here, finding the next point. I can see this point here really clearly. So I can make my triangle. So my rise is actually a drop. So that's a rise of negative 2. And my run is 1. So that means my gradient there is negative 2. So I can put that together to get my equation. So y is going to be equal to negative 2x plus 4. I can now do the same for line B. So line B is going up this way here. we can see 0 is where the y-intercept is. So that means it's going to be like c is equal to 0. And then the next point I can see really clearly, if we look up here and amongst the mess, we can see we can make that triangle. So it's got a rise of 3 and a run of 1. So that means your gradient for that one there is 3. So that means it's going to be y is equal to 3x. Technically it's plus 0, but plus 0 is just nothing, so we can get rid of that. So that's the two equations. So that there would get your achieved mark by now stating or showing the x value of the interception point. 0.8 is the next part. And the way we're going to do that is at the point of intersection, we know that the two y values are going to be the same. So if I use this point here as an example, that's where the red and the green line, so the red and the blue line overlap. You know, if I go up to the x-axis, that's the shared x value that they have, and they also have a shared y value at that point there. So that means, you know, these y values are going to be the same at the point we're interested in, which means these two expressions here with the x's are also going to be the same. So that means negative 2x plus 4 is going to be equal to 3, and at whatever x value that is, that's the shared x value that they have at that point. So let's start by simplifying the x's. So I'm going to go plus 2x to both sides. So we've got 4 is equal to 5x, and then we go divide by 5 to both sides. 4 over 5 is equal to x, and 4 over 5, I want to note, isn't 0.8. So when it says show means they've given you the answer of 0.8, and you've got to get there. But if you convert that to a decimal by doing division on your calculator, that shows you that x is equal to 0.8. So we're now on to the next question, and this question here, 32 to 33, so 32 to 35, this is all about Sean and Tom. They are traveling to South America for an OE prior to starting university. The way they've got their spending money, so this is all about their spending money. Sean currently has $5,000 of spending money and is planning on spending $65 per day. So the first question, 32, form an equation for Sean's spending money. Let y be the current balance and x be the number of days passed. So this equation here, if you think of, you know, your x and your y axes, Sean's money would start up here at $5,000, right? And it would slowly go down as he spends his money at $65 per day. So that $5,000 is actually going to be your y-intercept. So if you think of the equation, you know, y equals mx plus c. C is going to be $5,000, the amount of money he starts. M is going to be the gradient, the rate of change. And in this case here, we know that it's changing at $65 per day, but specifically negative $65 because he's going down by 65 each day. So that means your equation, so y is going to be equal to negative 65x plus 5,000. So if Tom's spending money is represented by the equation 4,000 minus 45x, explain what this would represent. So this one here looks a little bit different, but we can see here negative 45 is attached to the x, so that there's got to be my gradient, and that there is my constant. It can be switched around like this, so it's all good that it's the other way around. So the $4,000 tells us Tom's total spending money budget. So that's $4,000, and the gradient of negative 45 tells us he's spending $45 a day. So we're going to put that in a sentence. So let's go $4,000 spending money in total, and then he's aiming to spend $45 per day. I think that would wrap up. Aiming to spend $45 per day. So we can see his budget. He's got less money to spend, so he's got 4,000 instead of 5,000. That's why he's going to spend less money per day. So after how many days would they spend the same, or how many days would Sean and Tom have the same amount of spending money left? So remember, these here are both straight lines. So we've got Sean's one, which starts high and goes down at a greater rate, and then we've got Tom's one, which starts lower and it'll be a bit more level. So that's going to look like that. So we can see eventually those dots are going to cross each other at that point there. So that's going to be similar to the previous question that we had, question number 31, where these two equations here, we've got to make them equal to each other. So we know that Sean's money, all right, S for Sean, his one was y is negative 65x plus 5,000. Tom's one, y was equal to negative 45x plus 4,000. And just noting I switched around the negative 45x and the 4,000 just to make it easier. So at this point of intersection, I know that the y is the same, which means the x must be the same. So that means these two expressions here have to be equal to each other. So that's going to be negative 65x plus 5,000, and that's going to be equal to negative 45x plus 4,000. So the next step is to simplify all of the letters, and we've got two lots of letters here, so I can see that negative 45, negative 65, negative 65 is actually smaller than negative 45, so there's a bit of a trick there. So to get rid of that negative 65x, I've got to go plus 65x to both sides. So those would cancel, so I've got 5,000 is equal to 20x plus 4,000. I can now do minus 4,000 to both sides. So that means, so those cancel, so 1,000 is equal to 20x, which means x will be equal to 50. And just a reminder, this is in relation to days, so that there is 50 days. So that way, if we look at the graph here, so that point there is when they would have the same amount of spending money, and that there would have been 50. So now to question number 35, and there's two different ways to do question 35. It is the E question. I'll show you the easy way, but it's difficult to spot, and then I'll show you the harder way as well. So 50 days is when they've got the same, and the question here says, on what days will Sean and Tom have a difference of $200? So just a reminder, Sean is at the top there, Tom is down the bottom there, and if you go Sean minus Tom, at some point there'll be a $200 gap, so it might be there, but it will be the other way around when Tom eventually will have more than Sean as well. So there's actually going to be two possible answers. So just want to note, at 50, so when x is equal to 50, there is a zero difference, right? And we're trying to find out when there's a $200 difference. So remember the difference between their spending money. So if we go Sean minus Tom, that's going to be $65 per day minus $45 per day. That's a difference of $20 per day. So that means Sean, also Tom, is able to catch up by $20 per day. So that difference of $200, we're going to go $200 divided by 20, and that is equal to 10. So that means if we go back this way, that's going to be minus 10 days. And if we go forward this way, that's going to be plus 10 days. So I'm using my graph skills to get here. So that means if you're minusing 10 days, that's going to be 40 days to 60 days. So that's the quickest way to find it. So that means they will have a difference of $200 on days 40 and 60. So that's what we've got there. There is another way to do it. I won't step you through it the full by full version of it, but what you could have done is, we're looking for a difference of $200. So if we did Sean minus Tom, that there is going to be $200, right? And we can substitute in the equations for Sean and Tom. And also the other way around, Tom minus Sean would have been equal to $200. So we would have done it the other way around. If we formed an equation, obviously x would be the only letter of both of those, you'd then be able to get the two answers, and both of those would have got you to 40 and 60 like we did here. Now onto section D, and just a reminder, this is worth 20%, so you should be spending 20 minutes on the exam. This is basically the hard algebra section, the quadratics, double brackets, that sort of stuff. So we haven't put any multi-choice in here, just to save you a bit of time so we can test you on all the skills that we need to see. So by exploring the first and second differences, state the fifth term of the pattern. So we need to figure out this pattern here. So the first difference is always, well, how do you go from there to there? And in that case, it's a plus 4. There to there is a plus 8, and there to there is a plus 12. Now, none of these are the same, so that's when we need to start exploring the first differences. But to go from here to here, it's another plus 4, and there to there is another plus 4 as well. So that tells us the second difference is all the same, so this is a quadratic pattern. That means to go from here to here, we would have had to do a plus 16, because to go from there to there, it would have had to be another plus 4. So 24.5 plus 16 is 40.5. So that there is going to be 40.5, and that will get you a developing mark because it's just a pattern skill. Now onto question number 2. A triangle's height is 4.5 meters longer than its base. If the triangle's base is x centimeters wide, write an expression for the triangle's area.
So let's start by sketching this hypothetical triangle. So there's my triangle there. I know that the base is x from the question, which means the height would have had to be x plus 4, right? Because it's, 4.5, because it's 4.5 centimeters longer. The area of a triangle, hopefully you remember the formula, it's 1/2 of base times height, right? So if the area is 1/2 times base times height, so it's going to be 1/2 times the base, which is x, times the height, which is x plus 4.5. So that there would be the expression we're looking for. You could potentially expand this if you want to, but you definitely won't be getting any extra marks for that work. So question number 3, expand and simplify this. This is a double bracket, so we've got to deal with the x first. So let's go x times x. That there is going to be x squared. Then we've got x times -10. That's -10x. Then we've got 8 times x. That's plus 8x. And then that times that minus 80. So if you get to this point here, that's your developing mark. And that's because it's not simplified. We can simplify these middle things here. So -10 plus 8 is -2. So for achieved, you need to write x squared minus 2x minus 80. We're now been asked to fully factorize this expression here. Remember, factorizing is the opposite of expanding. So we need to try to get a double bracket answer. And the trick I do is we need to think of a bit of a number game. What multiplies to 36 but adds to 15? So we're trying to think of two numbers that would add to 15 multiply to 36. The way I do these is I always start by thinking of my numbers that multiply to 36. So firstly, it could have been, 1 times 36, but that adds to 37, so I know it's not that combination. I could have done, 4 times 9. That adds to 13, so it's not that. No, it's not that combination. Well, it could have been 2 times 18. That adds to 20, so it's not that. What about 3? So 3 times 12. Oh, bingo, that's exactly what we're looking for, right? Because 3 times 12 is 36. It also adds to 15. So that tells you your brackets. You're going to have x plus 3. That represents the 3 that you just found out there. You're then going to have x plus 12, and that represents the 12 that you've discovered there. So the next question, this one's actually a merit mark, so a bit of a trick to that. Fully factorize this, and it's a bit of a trick there because you've got the minus sign, and there's something else that'll come up later on. So what adds to -20 but multiplies to 100? So this one's going to be tricky. It's got to be negative numbers that we're exploring here. And the reason being, a negative times a negative is the positive 100, and negative plus a negative stays as negative. That's why it's -20. So let's start thinking of, ignoring the negative part of it, we need to think what numbers multiply to 100, and then basically the ones that add to 20, we can just put a negative sign in front of. So let's start off with the obvious, 1 times 100. That adds to 101, so it's definitely not going to be that option. We then got 2 times 50. That adds to 52, so it's not that. 3 doesn't work. 4 works. 4 times 25. That adds to 29, so it's not that. 5 times 20. That adds to 25, so it's not that. 6 doesn't work. 7 doesn't work. 8 doesn't work. 9 doesn't work. 10 works as well, right? 10 times 10. And this looks like a great answer because 10 plus 10 gets me to 20. So that means my answer here is actually going to be -10 times by -10, because negative times a negative is the positive 100, and then plussing them together gets there. So that means my brackets are going to be x minus 10 and then x minus 10. So if you get to this mark here, you've only got an achieved mark, unfortunately, and that's because we haven't recognized these are actually the same bracket, so that means this is a perfect square. So that means if we do that, it needs to be x minus 10, and we've got to square it like that, and that there would be a fully simplified version of that. So now into question number 6, we're looking to solve, and these questions here, they look difficult. You're like, geez, how are you going to start that? But just a reminder, I teach my class the split method, so when it's factorized, whatever the first bracket is, so the first bracket, x plus 1, just make it equal to 0. And then this here is a one-step equation that we learnt in year 9, and you can go ahead and solve that. So I can solve that by doing -1 to both sides, right? So cancel that out. So x will be equal to -1. So that's my first answer, but because it's a quadratic, we know there's got to be 2 answers, and the second answer comes from the next bracket. So again, x minus 7 is the second bracket. I'm going to make it equal to 0, and then I'm going to use my algebra to solve this. So it's going to be +7 on both sides, isn't it? So they will cancel, +7. So x is equal to 7. And like that, I've stated my 2 answers for this quadratic. Now into question number 7. This one's a bit harder because your quadratic as we've done in the previous question, it's got to be factorized before we can do that split to solve. So we need to factorize this here, and we need to think, well, what adds to the positive 1x and multiplies to the negative 30? So I'm going to start by thinking of my factors of 30. So it's going to be 1 times 30, so it's not going to be that. 2 times 15, it's not going to be that because that has a difference of 13. And then we've got 4 doesn't work, or 3 works, doesn't it? 3 times 10, that's got a difference of 7, so it's not that. 5 and 6, that adds or multiplies to 30. Perfect. So I think it's going to be this one here because it adds to 30. It's got a difference of 1. I've just got to figure out the minus signs, kind of like I had to do in the previous one. So how could I get these to add? So could it be, negative 5 and positive 6, or could it be positive 5 and negative 6? So these ones here would add to positive 1x, but these ones here would add to what? Negative 1x, because that negative number is bigger. And I'm looking for the positive version because I've got a plus sign up there, so it means I can cancel that. So that means when I factorize it, it's going to be x minus 5, and then it's going to be x plus 6, and that there is equal to 0. And then now that it's factorized, I can split it off. So x minus 5 is equal to 0. So I'm going to add 5 to both sides to find this particular answer. So that means x is equal to positive 5. I'm then splitting this up. So x plus 6 is equal to 0. So minusing 6 to both sides. So that means x is equal to negative 6. And like that, I've got my 2 answers for that particular quadratic. Now on to question number 8, and this is when we're trying to determine the equation of the parabolas. We've got 2 parabolas. Remember, you got these in the formula sheet, so your formulas could either be y is equal to x plus b squared plus c. That's for the vertex method, or it could have been x plus b, x plus c. So let's start with the dotted parabola, because that's the first one up here. The dotted one here. So the question you've got is, which information do you have? Do you have the x-intercepts or do you have the vertex? And we've actually got both here. We can see the x-intercepts clearly here, but we can also see the vertex here. So we could actually come up with either of these to get a valid answer. Let's pick the vertex method just because it's there first. So I'm going to jot down my formula. Y is equal to x plus b squared plus c. My b and c values are what we're trying to find out here. So just a reminder, C relates to your vertical movement, your up and down movement. So that vertex there should have been at the origin, but it's been moved down by 9. So that means C is equal to negative 9. It's then also been moved across to negative 1. So that means B value, just a reminder, your B values are always your opposites. So because it's gone to negative 1, that means B is going to be positive 1. So that means your final answer, Y will be equal to x plus 1 squared minus 9. I can now do the same for my solid parabola, so that's the smaller one up the top there. The issue is we got here is I can see the vertex and I can't see any x-axis. So the previous question I could pick which formula I would have used and I would have got the right answer either way. But this one here, I can't use that x-intercept one. So that's not going to work here. I can only use the vertex method. So we're going to use the same formula. So we've got, I always write it down, x plus b squared plus c. Again, my vertex there should have been over here at the origin, but it's been moved across 3 and then up 1. So because it's been moved up 1, I know that c is positive 1. It's been moved over to positive 3. And remember, your b is your opposite. That means b is negative 3. So that means your answer here, y is equal to x minus 3 squared plus 1. So now moving on to question number 9, Jacob is trying to factorize x squared minus 81. His working is below, however, the teacher has marked it incorrect. Explain why Jacob is wrong. So this looks pretty good, right? So if you go, x times x, that's x squared. 9 times 9, that's 81. So his answer looks okay. But the issue he's got here is, this here is called a difference between two squares. And this here is actually a perfect square. And these here are different concepts. So this one cannot be equal to the other one there. So let's go ahead and factorize this. So if we think about the x squared minus 81, that's actually the same as x squared plus 0x
minus 81, right? Because there are 0 x's sitting in the middle there. So now if you think, well, what adds to 0 and multiplies to 81? Hopefully thinking the same as me, it's going to be negative 9, positive 9. They add to 0. So that means your double bracket will be x minus 9, x plus 9. So we can see here, one needs a plus sign and one needs a minus sign. So that's why his answer is wrong, because it's not the same thing twice. It's not a perfect square. It's a difference between two squares. So let's communicate that. So Jacob is wrong. As x squared minus 81 is not a perfect square. It is a difference between two squares. Which requires double brackets with different signs. Okay, so we've done that one there. So that's worth a merit mark. So I think the way the marking schedule works here is if you somehow come up with this being wrong or factorize this correctly, I think that's your achieve mark, whichever way you did it. And then if you communicated what the issue was, that there was your merit mark there. So we're now on to question number 10. This is the first of the excellence questions, and we've been asked to fully simplify this here. And before I get into the messy part of it, straight away I can see everything is even, right? 2, 10, 12, 2, 4. So what I'm going to do is I'm going to start by just dividing everything by 2. So let's divide all of that by 2, and let's divide all of that by 2. So let's get rid of that. So that top there is going to become x squared plus 5x plus 6. And the bottom there is going to become, what's that, x squared plus 2. Now, it would be incorrect just to cross out the x squareds there. That's definitely not right. And I'll give you a quick example of why that's not right. So let's go 2 plus 4 over 2. So that's a bit of a fraction. So this here, if you followed your BEDMAS right, you do the 2 plus 4 first, which is 6, over 2, which is just 3. If you cross out the 2's just by itself like that, apparently it's just 4. So that's why it's mathematically correct. You can't just cross them out. You can only cross them out if they are factors. So we don't have any factors here. And your clue, factors is a good clue of what skill you need to show, is you need to be factorizing these. You need to factorize the top and factorize the bottom. So I won't bore you with the factorizing process, but the top would factorize to x plus 2 and then x plus 3. And the bottom, there's no constant at the end, so it's just a single bracket when I'm going to take out x, so that there would be x bracket x plus 2. I can now see the top and bottom both have a common bracket, so those are the common factors that we can cancel out. So we can get rid of x plus 2 and we can get rid of x. So that there is going to be x plus 3 over x. And again, don't make the same mistake. Again, some people like to cancel out this and this, leaving us with 3. Again, that's the mistake you should desperately avoid, because you'll lose your excellence mark if you do that. We're now on to the very final question of this exam, question number 11. It's an excellence question here. Basically, a bridge's height can be modeled by this equation here. At what height would the bridge have a width of 6 meters? So this one's going to be pretty rough. But the trick here was to actually draw the parabola. So if you think of your x-intercept method, you had x plus 1, x plus 2. The 1 and the 2 told you the x-intercepts were at -1 and -2. So we've got that here, but this bit up front is kind of like the same as h is equal to negative x plus 0, right? And then x minus 10. So that tells you your x-intercepts are going to be at 0 and 10. So if we sketched out that parabola, so it's a negative parabola as well, so it's going to be upside down. So it starts down here at 0, it goes up, and then starts going down over there, and that there would be at 10. So the next bit of information we could figure out is the vertex of this parabola is going to be key, because this shape is going to be symmetrical, and that's going to have to be in between 0 and 10. So that's going to be the center, and that's because it's symmetrical, as I said before. And figuring out when does it have a width of 6 meters, this is going to be tricky. So a width of 6 meters would be some kind of, imagine a bit of wood there that's 6 meters, that's sitting in between the parabola. So that means there's going to be 3 meters on this side and 3 meters on this side. So that means if you go down here, when x is 2, And when x is 8, we're going to have that width of 6 meters there, right? Because the difference between 8 and 2 is 6 meters. So now that I've got that, I now need to figure out the height. So that's this markup here. And that's when we need to go back to this formula here. So h is equal to negative x bracket x minus 10. So height is what we're trying to find out, right? And we know this height is going to occur when x is equal to 2. So let's substitute in 2. So it's going to be negative 2, and then it's going to be 2 minus 10. Don't substitute in 1, 2, and 1, 8. That is going to get you a wrong answer. If you did pick 8, make sure you do 8 and 8. But you get the same answer either way. So it's going to be negative 2 times negative 8, or negative 18, but negative 8, which gets you to negative or positive 16 as a height. So 16 meters is when you're going to have a difference of 6 meters. So that there is up there. So that wraps up all of this video. Hopefully you found these useful. Just a reminder, in your exam, there's going to be an optional section following this that won't count towards your overall mark, but it's a really good way for extension students to differentiate themselves to see who's kind of like top of the top and who's well ahead of the curriculum and where they need to be.